Purifying Tomorrow, Strategies for Sustainable Water Treatment. Today, Aquapure will be presenting a more sustainable, efficient and budget-friendly innovation for treating wastewater. In Malaysia, remote and underdeveloped areas face significant challenges in wastewater management due to high operational costs, limited resources and the lack of large-scale treatment systems. Untreated wastewater poses serious environmental and public health risks, highlighting the urgent need for sustainable, scalable treatment modules to mitigate these hazards and promote long-term water security. From these, 3 objectives are drawn out to help solve the crisis. The first objective is to introduce a new and improved mechanism to enhance the purification of wastewater. SDG 9, Industry, Innovation and Infrastructure. The second is to recreate resource-efficient and sustainable wastewater treatment systems for improved sanitation and rural communities. The last objective is to ensure rural populations have access to safe and sanitized water. SDG 6, Clean Water, and SDG 3, Good Health and Well-being.
The problem now is, how do we ensure that the wastewater will get treated properly with minimal energy consumption and low in cost? We propose a solution where the wastewater will go under 3 stages: primary, secondary and tertiary treatment. Firstly, the primary treatment, septic tank. The mechanism of this process is the wastewater will flow inside the septic tank. Inside the septic tank, large solids and particles will be deposited and accumulate at the bottom of the tank and will be removed. Next, the treated water will go to the next stage, whereas the waste is then removed. Now, the next stage is the natural filtration using coconut coir. Coconut coir is a natural fiber extracted from the outer husk of the coconut. The wastewater will go through the filter with the coconut coir, where tiny dirts and particles will be extracted. In this stage, up to 90% of the pollutants are removed. Then goes the final stage where the wastewater will flow under a UV light. The UV light will disrupt the DNA chain of the microorganism left in the water. Finally, the treated water will be sent to rural homes and farms for daily use.
Now, let's break down our proposed wastewater treatment in our first primary treatment, which is septic tank. Septic tank effectively removes soluble solids through sedimentation and some floating materials through flotation. It also could reduces the biochemical oxygen demand (BOD) and total suspended solids (TSS) to a certain extent. It could provide anaerobic digestion, breaking down some organic matter. For the environmental impact, if not properly maintained, it can lead to groundwater contamination due to leaching of untreated wastewater. Sludge accumulation requires periodic removal and proper disposal to prevent environmental issue because anaerobic digestion produces methane, a greenhouse gas, though in relatively small quantities in household septic systems. How about its cost? Septic tanks relatively low initial investment compared to centralized system. It just requires periodic pumping and sludge disposal, which adds to operational costs. This is why septic tanks are well suited for rural areas due to their low-tech nature and ability to function independently. Some of the improvement that we could add in our septic tank is provide clear guidelines and training on proper installation, maintenance, and sludge disposal. Second, we could consider using improved septic tank designs that enhance treatment efficiency. Natural filtration that we'll cover on our secondary wastewater treatment is coconut coir. Coconut coir acts as a natural filter, removing remaining suspended solids and reducing BOD and COD, chemical oxygen demand. It could provide a large surface area for microbial growth, which further enhances pollutant removal and can remove some nutrients like nitrogen and phosphorus that only can be used for their plants. Thus, coconut coir uses a natural, readily available and biodegradable materials where it can reduce the environmental impact compared to conventional filtration methods that require chemical additives. It also a proper disposal of spent coconut coir is essential to prevent environmental issues. For its cost, coconut coir is generally inexpensive and locally available in many tropical regions, and it has low energy requirements for operation and periodic replacement of coconut core is necessary, but the cost is still relatively low. For some of the improvement that we could add in our natural filtrations is we can optimize filter design and flow rates for maximum efficiency. Besides, we can conduct research on the long-term performance and lifespan of coconut coir filter in different conditions. And lastly, we could provide training on how to properly replace the coconut coir. Lastly, let's look at for our tertiary treatments of the wastewater by using UV disinfection. UV disinfection is highly effective in inactivating bacteria, viruses, and other pathogens. It does not introduce chemicals into the water and just provides a high level of disinfection, ensuring water safety. It also environmentally friendly as it does not produce harmful byproducts and low energy consumption compared to other disinfection methods if we're using efficient UV lamps. How about its cost? Initial investment in UV disinfection equipment can be moderate, but in operational costs are relatively low and mainly for electricity and lamp replacement. This is why UV disinfection can be implemented in rural areas, especially with the availability of solar-powered UV system. Here are some improvements that we could add in our UV disinfection. First, promote the use of energy-efficient UV lamp and the solar-powered system to reduce electricity consumption. Ensure proper maintenance and cleaning of UV lamp to maintain effectiveness. And last but not least, we have to provide training on how to maintain the UV system. So, for overall justification for the three treatment, which is the combination of septic tank, coconut coir filtration, and UV disinfection, provides a multi-barrier approach to wastewater treatment, ensuring effective removal of pollutants and pathogens. The system utilizes natural materials and processes, which is we can minimizing environmental impact. And also, the cost of the system is relatively low cost compared to centralized system, making it affordable for rural communities. And the system is simple, low-tech, and adaptable to rural conditions.
In conclusion, the improved solution that Aquapure has proposed for wastewater treatment is that first, we use a septic tank to separate large waste from water. Then, we further separate small dirt particles from the water using a coconut coir biofilter. And last, we disinfect the water free of harmful bacteria using UV light. These three stages would most likely succeed in effectively removing the contaminants in a more budget-friendly and sustainable way, successfully supplying clean and safe water to the public. The SDGs mentioned are fulfilled accordingly. With this, the rural population will have access to clean, safe water and low risk of waterborne disease, guaranteeing long-term feasibility and scalability and greater environmental resilience due to the local and natural materials being used along with low energy consumption, securing a sustainable, clean future. And that's it. Thank you.